Hello everyone, and welcome. In this video, we'll be diving into the world of Power BI, focusing specifically on one of the most important concepts, transform data. This session is brought to you by ZoomInData, your space for learning business intelligence and data analytics. So, let's get started and understand how Power BI connects to different data sources and why this process is so essential in today's data-driven world. First question: what is the difference between transform data and data transformation in Power BI? Transform data refers to the actual button in Power BI desktop that opens the Power Query editor. It is a user interface action that allows you to start editing and shaping your data. Data transformation, on the other hand, refers to the overall process of preparing data. This includes cleaning, reshaping, merging, splitting, filtering, and structuring the data so that it becomes analysis ready. Transform data is simply how you access Power Query, whereas data transformation is the set of tasks you perform in Power Query. Second question: what is Power Query and how is it different from DAX? Power Query is Power BI's ETL, extract, transform, load, layer used to clean, reshape, and prepare data before it loads into the model. It operates using the M language, which is built for transformation logic. DAX, on the other hand, is used after data is loaded into the model. It performs calculations such as measures, calculated columns, and calculated tables for analytics and reporting. Power Query works at the data import level, changing the actual structure and content of tables, while DAX works at the semantic model level, enhancing analysis using formulas. In simple words, Power Query transforms the data, while DAX transforms the numbers and logic applied to the data. Third question: what is query folding and why is it important for performance? Query folding is the process in which Power Query pushes transformation logic back to the source system, for example, SQL Server, allowing the source to execute transformations instead of Power BI handling them locally. This is extremely important because databases are designed to perform heavy operations such as filtering, joins, grouping, and aggregations much faster than Power BI's memory engine. When folding happens, Power BI only retrieves the final, filtered result, significantly reducing refresh time, memory usage, and network load. Without query folding, Power BI would need to load the entire dataset first and apply transformations afterwards, which leads to slow refreshes and inefficient processing. Fourth question: what operations commonly break query folding? Query folding typically breaks when Power Query performs transformations that the underlying data source cannot translate into its native query language, like SQL. Operations such as using index columns, performing row-level operations using non-native functions, or adding complex custom columns often break folding because SQL cannot express these operations directly. Merging a SQL table with a non-foldable source such as Excel or JSON also breaks folding because combining heterogeneous sources prevents the database from executing the logic. Certain built-in transformations such as unpivot, group by, or extract text operations may also break folding when they cannot be represented in SQL syntax. Fifth question: what is the difference between duplicate versus reference queries in Power Query? A duplicate query creates a completely independent copy of a query, meaning any future changes made to the original query do not reflect in the duplicate one. It is useful when you want to create a similar query but modify it without affecting the original. A reference query, however, creates a dependent query that inherits all steps from the original. If you modify the original query, the referenced query automatically uses the updated result. Reference is typically used in staging architecture, where you load data once and then create multiple transformations from the same base query. Duplicate increases redundancy and maintenance effort, while reference promotes reusability, modular design, and cleaner architecture. Sixth question: what is the mashup engine and how does it execute queries? The mashup engine is the core engine behind Power Query that interprets M scripts and executes data transformation steps. It processes each applied step sequentially, building dependencies as transformations progress. When possible, the mashup engine attempts to delegate operations to the data source. This is query folding. If delegation is not possible, the engine loads the data locally and performs the transformation in memory. The engine manages data buffering, caching, and memory usage during refresh, ensuring transformations occur in a structured and efficient manner. It also handles error detection, external data access, and connection management, making it the backbone of Power Query's ETL process. Seventh question: what are staging queries and why are they used in enterprise BI models? Staging queries are queries created specifically to import raw data from source systems without applying business logic or heavy transformations. They act as the raw layer of the ETL process. They improve performance because data is loaded only once, and all other transformations are done through reference queries, reducing redundant database calls. Staging helps maintain clean, structured, and modular ETL pipelines where source extraction and business transformation are separated. Enterprise BI systems prefer staging because it improves maintainability, promotes reusability, supports incremental refresh, and makes debugging easier. Eighth question: what is data profiling and how do column quality, distribution, and profile help in cleaning data? Data profiling provides statistical and quality insights into your dataset to help identify issues such as missing values, errors, duplicates, or outliers. It enhances data understanding before performing transformations. Column quality shows percentages of valid, empty, and error values, helping detect columns that may require data cleaning or type corrections. Column distribution reveals the spread of values, uniqueness, and frequency patterns, making it easier to identify anomalies, inconsistent values, or unexpected categories. Column profile provides detailed metrics such as minimum, maximum, count of distinct values, and overall summary statistics, helping validate data correctness and prepare it better for modeling. Ninth question: what is parameterization in Power Query and why is it needed? Parameterization allows you to define dynamic values, such as file paths, folder names, server names, or dates, and use them within queries to make your ETL process flexible. It helps automate repetitive tasks, for example, automatically loading new monthly files without manually editing the query each time. Parameters enable environment portability, meaning the same Power BI report can move between development, UAT, and production by simply changing parameter values. It also improves maintainability by reducing hard-coded values and making updates easier and less error-prone. 10th question: how do you combine multiple Excel or CSV files from a folder into one table? Start by selecting Get Data, then Folder, point to the folder path, and Power Query automatically lists all files along with details such as name, extension, and date modified. Then click Combine and Transform, which uses a sample file to detect structure and generates an automatic query that extracts the content of each file. Power Query applies transformations from the sample file to all other files using a generated helper function, ensuring consistency across files. Finally, review the output table, remove unnecessary columns, like source name if not needed, and load the combined dataset to Power BI. 11th question. How do you handle schema drift when combining files? Power Query uses a sample file as the base schema, but if other files have extra or missing columns, use choose columns, then choose columns, then maintain all columns to keep the query flexible. Dynamically handle schema changes by using table, column names and table, reorder columns with missing field, ignore to avoid errors when some columns do not exist. For extra columns, detect and isolate them using list difference to identify new unexpected fields and flag them for quality checks. When files have missing mandatory columns, create them manually using add column then custom column with default values to standardize the schema. 12th question. How do you remove errors from a column without deleting valid records? The Remove Errors option in Power Query removes only the rows that contain errors in the selected column, while all valid records remain intact. When errors need to be retained but corrected, the Replace Errors feature can substitute error values with a fallback such as null, 0, or any custom expression. For complex or inconsistent error patterns, the try, otherwise construct in a custom column allows errors to be captured and replaced dynamically without discarding entire rows. Data profiling tools help identify which columns contain the highest error percentages, enabling targeted error handling while preserving the full dataset. 13th question. How are two or more queries merged using multiple keys? The Merge Queries option allows selection of two tables and multiple key columns in the same order, enabling accurate alignment of matching records. Power Query creates a composite key from the selected columns, functioning similarly to multi-column joins in SQL for precise row matching. Various join types, such as left join, inner join, right join, and full outer join, can be applied depending on whether only matched rows, unmatched rows, or the full dataset is required. After the merge operation, the resulting table can be expanded to include only the necessary fields, preventing the model from being loaded with unnecessary columns. 14th question. How is a reusable custom function created in Power Query for repeated cleaning tasks? An existing query containing the transformation steps is first generalized by replacing fixed or hard-coded values with parameters, and then wrapped inside a function definition using the equals greater than syntax. The query is then renamed appropriately, for example, fxCleanData, so that it appears as a callable function within the query's pane. This custom function can be invoked by other queries, particularly during file combination processes, by passing the current table or input value as an argument. Custom functions enable consistent and reusable data cleaning operations, such as trimming whitespace, standardizing date formats, renaming columns, or handling null values across multiple datasets. 15th question. How are multiple columns unpivoted dynamically in Power Query? The process begins by selecting only the static identifier columns, such as product or region, and applying unpivot other columns, which converts all remaining fields into attribute value pairs. To ensure dynamic behavior, only the fixed key columns are selected. This prevents dependence on individual column names and allows newly added columns to be automatically included in the unpivot operation. Power Query handles this using the table unpivot other columns function, which ensures that the transformation remains stable even when the underlying schema expands. This dynamic unpivoting approach is widely used for converting wide tables such as monthly sales columns, Jan, Feb, Mar, etc., into normalized, analysis-friendly structures. 16th question. Our SQL query initially supports query folding, but after adding a new transformation step, query folding breaks. How should this situation be troubleshot and fixed? The applied steps pane should be examined to identify the specific transformation step that caused query folding to break. Often, folding breaks when a transformation cannot be translated into the SQL dialect of the source system. Non-foldable steps should be either removed, modified, or moved after all foldable transformations so that the database can execute as much logic as possible before local processing. Unsupported transformations can be replaced with SQL-compatible operations, such as simple filters, joins, and aggregations, which are capable of folding. The View Native Query feature can be used to verify which steps are still being executed at the source and to ensure that query folding is restored for performance-critical operations. 17th question. A Power Query refresh is taking an hour to complete. How can slow steps be identified, and what strategies can be applied to optimize performance? Query diagnostics in Power Query can be enabled to measure the execution time of each transformation step, which helps identify the steps that are consuming the most resources. Performance can be improved by applying row filters and removing unnecessary columns early in the query so that subsequent transformations process a smaller volume of data. Maintaining query folding wherever possible ensures that transformations are pushed to the source database, leveraging its processing power rather than executing locally in Power BI. Multiple small transformations can be combined, and resource-intensive row-by-row operations, such as complex custom columns or text transformations, should be minimized to improve efficiency. 18th question. If only the last 3 months of data need to be loaded from a 10 million row table, how can this filter be pushed to the source to optimize performance? A filter on the date column should be applied as the first transformation step to ensure that only relevant rows are processed, which is critical when working with large datasets. The filter should be implemented using operations that support query folding, such as standard comparison operators, e.g., greater than equals, less than equals, so that the database performs the filtering rather than Power BI. The View Native Query feature can confirm that the database is executing the filter before data is imported into Power BI. When using incremental refresh, range parameters for start and end dates should be configured so that only the required partitions are loaded during each refresh cycle. 19th question. 2 different data sources have varying column orders and missing fields. How can these datasets be standardized automatically for analysis? Common identifier columns should be identified, and an expected schema should be defined, including mandatory and optional columns. The table reorder columns function with the missing field. Ignore option can dynamically reorder columns while ignoring missing ones, ensuring consistent column order across all sources. Missing mandatory columns can be added with default values such as null or zero to standardize the schema between sources. After standardization, tables can be appended or merged confidently, ensuring that future changes in the source structure do not disrupt the process. 20th question. How should a Power Query workflow be designed when data comes from multiple sources, such as SQL, SharePoint, and Excel? Separate staging queries should be created for each source to import raw data with minimal transformations. This modular approach improves maintainability and performance. Data cleaning and standardization steps, such as type changes, column renaming, and filtering, should be applied at the staging layer before combining the data from multiple sources. Reference queries should be used to create transformations based on staging queries, allowing multiple dependent queries to reuse the same clean data without duplicating logic. When combining datasets, careful attention should be given to schema alignment, data type consistency, and maintaining query folding where possible to ensure optimized performance. 21st question. A dataflow refresh completes successfully, but the corresponding dataset refresh fails. How can it be determined whether the issue lies in Power Query or the data model? The refresh error messages in the Power BI service should be reviewed to determine whether the failure occurs during Power Query transformations or during dataset level calculations. If the issue occurs in Power Query, the applied steps, data source credentials, and query folding status should be examined to identify problems such as schema changes or broken connections. If the issue occurs in the dataset, relationships, calculated columns, measures, or DAX calculations should be inspected, as errors in these areas can prevent the dataset from refreshing even when the dataflow succeeds. Refresh history and diagnostic logs should be analyzed to pinpoint the failing step, isolate the source of the error, and apply targeted fixes without impacting the entire workflow. Thank you for watching this session. If you have any questions, you are welcome to contact ZoomInData through our website, email, or phone. We're always here to support your learning journey. See you in the next video.